Hello and welcome to this new video. Today we are going to talk about the third extended file system, history, schematics, and more coming up. So yes, today we are talking about EXT3, all the changes, the features, and everything that makes this file system great. Now, to be able to understand the changes inside of EXT3, we need to understand where it comes from, and that's from EXT2. I have a whole video on the subject that you should really watch, but in any case, for this video, you need to understand that EXT2, when it was released in 1993, was a really great file system. And the reason why it was great was because of its simplicity. Now, simplicity to our modern brain isn't really something that we think about, right? Because we see BTRFS, Bcachefs, those insanely complex file systems, ZFS. We see them and they're not simple at all, and that's a good thing, right? We want them to have as much feature and to be as complex as possible. Now, the big reason why simplicity was important is because the hardware was different. So your hard drive, you wouldn't have any solid state drive, which we mostly use today. You wouldn't have fast hard drive. Their hard drive were 100 times, if not even less, the speed of what we have today. And their hard drive were also way less reliable than what we have today. Today, if you have a broken sectors on your hard drive, well, that pretty much means that your hard drive is probably dying because it's not supposed to. Now, for the older hard drive, you would get the hard drive brand new out of the box with a couple of broken sectors and even more on the way, because throughout the life of your hard drive, you would get a couple of broken sector here and a couple of broken sector there. That was just normal. Now, with that reality, simplicity gives us two things. The first thing is it allows us to reduce computation and reduce the amount of time that you're going to seek on the disk. Because if you have a very simple way to put things on your drive, you probably don't need to check 15 places to get it. It's going to be fairly simple. So you're going to get okay performance. The second thing that it gives you is it gives you more safety for your data. Now, to be able to understand that, let's just make a quick example. Let's have two file systems. We have a simple file system and we have a very complex one. Inside of each file system, we have the actual data that is on a file and we have the structure of that file system. So both of them are, of course, needed in order to manage our file system. So let's say that we introduce a broken sector or a random corruption inside of the file system structure. Now, for the simple file system, it's something that is pretty straightforward to correct. Because of the simplicity of the file system, it's easy to be able to replace that data, or at least make sure that the data that is lost because of it is limited. Now, for a complex file system, good luck with that. You're probably going to lose a large part of your data just because of a small corruption, or at least it decreases your capacity to repair your hard drive. Now, with that in mind, we can kind of see where EXT2 can shine, because EXT2 was so simple that it was almost impossible to kill the file system if there wasn't a corruption directly where your data was. So you wouldn't lose a large part of your data, you would really only lose data where the corruption would happen, which is really great. Now, with that in mind, the EXT devs gave themselves two rules for any features that they would want to add to the new file system that would become EXT3. The first one is that whatever would be implemented would need to be simple. Of course, if you have a file system that is great because it is simple, you don't really want to add complexity to it to make it not simple. So that's the first rule. The second rule is that it needs to be forward and backward compatible with EXT2, meaning that you're supposed to be able to take your EXT2 partition, transform it into EXT3, and then revert back to EXT2. With those rules, they released EXT3 in 2001 with Linux 2.4.15, which was pretty much only one feature that was added, and that's the journal. Now, the reason why anybody would need a journal is because journals are really important to make sure that you don't lose data in the event of a crash. Now, let's just make an example to make it clear to us. So let's say that we were to write some data in the middle of a file. And let's say that our computer is to crash while we're writing that data. Well, when we boot back up, we have no idea of what data is old data and what data is new data. And at that point, we pretty much have one useless file because it's been partially written with the new data. So to be able to fix this, what they did is they added a journal. Now the journal is just you writing what you're going to do with an end character and then doing it. So for example, you are going to write, I am going to write file X with data Y, and then you put a dot to say that you have finished that command. So you write the information at the appropriate place, and then you're done. But let's say that you crash in the middle of that write. Well, when we boot back up, we would be able to see that you have a journal, and we would just have to re-execute the journal in order to get to a usable version of that file. So that way, if anything is written on the actual file system, it ensures that you keep your data. You're not going to corrupt some kind of file because we haven't written it completely. Now there's also two other things that a journal helps. The first one is faster recovery, because now you don't really have to do a full checkup of your file system after a crash. With EXT2, you would need to scan the whole hard drive from start to finish in order to be able to go back to using it, because we had no idea where or what you were doing at the moment of the crash. Now with EXT3, we look at the journal, we re-execute the journal if it exists, and then we can go on our way and actually work with the file system. That cuts down on the recovery time a lot. Now the second thing that it solves is it solves the orphaned file problem. You can have a weird situation where you can have an inode that is open, but the directory that it's in gets deleted. Now what that does is that you just have a free inode that doesn't have anything pointing to it. Now, if you're going to close your program, of course that inode will get deleted, or if you unmount the partition, the inode will get deleted. But if you crash, you would just get a free inode inside of your file system that could never be freed. Now a journal solves this because you can actually write inside of the journal, hey, please delete the inode, and if ever you were to crash, it would delete the inode when you mount the file system back up. So that way it reduces the amount of problems that you can get because of crashing. Now, there's also an interesting thing about the journal inside of EXT3, because the journal is managed by something called JFS. Now, JFS is kind of a journal handler that is completely outside of EXT3. It can be used for anything from, of course, EXT3, but any other file system or even LVM. So with that in mind, the devs of JFS made it so that you could have one journal for multiple file system, or you could have one journal that is outside of your given file system or outside of your hard drive. So the journal code is really flexible and you can pretty much do whatever you want with it. So it's interesting to see that most people don't even know that feature and just use EXT3 normally. But if you want, you can just throw the journal on another drive and call it a day. Now the other big feature with EXT3 is H-trees. We're not going to talk about them today. They're going to have their own videos because they are a little bit complex. They're not something that you could wrap your head around. Inside of this video, a dedicated video will make way more sense for this concept. But what you need to know for this video is that the reason why they exist is because EXT2 and EXT3 had a problem when you had really big directories. So if you have a directory with, let's say, 2000 file, because it's doing a linear search through all of your entries, it would take a long time in order to go through all of the directories entry. Now, that has been solved by H-trees. We're going to talk about all of that in another video, probably next week. So, of course, subscribe and stay tuned for that. But the next thing that we're going to talk about is improving scalability. Now, why would scalability be important? Well, we are talking about 2001 and around those years. So scalability was not really something that we thought about that much because we didn't have multi-core CPU. Why would we try to optimize for some parallel load while no real CPU is going to use it? Well, more and more servers would have this capability. Now, they would most likely have 2 CPUs or more, but they would be physically different CPUs. In the consumer market, there was nothing with multiple cores, but we saw the writing on the wall that there would be multiple threads, so more and more scalability was actually something that people talked about and needed to optimize for. Now there are 3 things that was optimized for EXT3 and that we are going to talk about today. The first one was the fact that they stopped updating the superblock inode and block count. Now, if you've watched the EXT2 video, you know that inside of the superblock, we have a count for inodes and for blocks. Now, that count gets updated each time that we're adding an inode or that we are writing to a block. Now, let's say that we have 2 cores at the same time trying to write onto the superblock. Now, of course, they cannot do it at the same time, so they would lock one or the other core in order to be able to be the only one writing at a certain time. Now, of course, that's not optimal because we want to be able to be multiple core writing at the same time onto our hard drive. Now, to be able to do that, what they did is they completely stopped updating the inode count and the block count into the superblock, and they only update it at the block group descriptor level. Now remember, we have those 2 levels, right? We have the block group descriptor and we have the superblock. So we only upgrade on the block group descriptor, which has more chance of not being the same place as the other core is trying to write. So that way we can be multiple core doing the same thing. Now you may ask yourself, hey, well, there's kind of something broken, right? We cannot just drop the superblock and just say that it doesn't work anymore. That's right. So what they did is they only update the superblock inode and block count if you're either asking for it through a system call or if you're unmounting your file system. So this is how they're keeping their EXT2 compatibility, is because if you're unmounting it, then you will be able to mount it back with EXT2 without an issue because your superblock will be updated. Now the second way that they would optimize for parallel load would be to replace big kernel lock by smaller lock inside of the journaling code. Now, big kernel lock is not something that we know inside of a modern Linux kernel because it doesn't exist anymore. The idea of a big kernel lock is a lock that blocks the whole kernel whenever a core is using a specific kernel function. Now, that's really not a good thing, and there's obvious reason why it was phased out of the whole kernel altogether. It's because we want to be multiple cores doing things inside of the kernel at a given time. Of course, if you have a program trying to write data on the drive and you have another program though doing something completely different but still using the big kernel lock, well, you're kind of screwed, right? At that point, you're waiting on something completely unrelated to what you're doing, so that's not good. So putting smaller lock inside of the journal code makes things go faster for any kind of parallel load. Now, one example of this, which is the third point that we're going to, is the fact that they removed sleep on and replaced it by wait event. Sleep on was another unsafe command that they removed from the kernel. Now, the big reason why they removed sleep on is because you could only use it like this. You would use a while command, and after that you would put your sleep on command waiting on the queue. Now, the big issue here is that if ever your queue would come back saying, yes, you're good to go, between the while and the sleep on command, you would be in a weird situation where you're in an infinite loop and there is nothing you can do. So the solution to that was to use big kernel locks. Now, of course, if we're removing big kernel locks from everywhere, we really don't want to be using a system that needs big kernel lock in order to work. So wait event is another way to do things. It doesn't require big kernel lock and it makes things way faster. How much faster does those 3 patches actually make things? A 10x performance boost. So that's how improving the scalability of your code actually made a real big difference. Now, another thing that we want to talk about today is preallocation and reservation, which is something that we have completely skipped into the EXT2 video. Now, inside of EXT2, there is a preallocation code, which is there to make sure that we don't mix blocks if you're writing on the same directory. So let's say that we're trying to write 2 files at the same time in the same directory. What could happen is that you would have one block that is for file 1, block 2 that is for file 2, block 3 that is for file 1, and you can see how they're all interleaved. And that's not a good thing, right? Because we're using mechanical hard drive, and if we don't have a contiguous big block of data, we are slowing down how fast we can read our data. So to fix that, they use preallocation. What they did is, inside of the block bitmap, they would pre-allocate a couple of blocks in front and then correct it at the end of the write. So that way, you would be able to write your full file, or at least a big part of your file, in a contiguous block, and then write your second file a little bit later with the same perks. Now, if ever you were to crash in the middle of that process, EXT2 would just do a full repair anyway, so it would be able to detect the errors inside of the block bitmap and correct them. Now, this is where we can see that it doesn't work with EXT3. EXT3 doesn't do a full checkup of your file system, so we cannot use preallocation because we would have a corrupted block bitmap. So the solution there is to completely remove that process from the hard drive and 100% making it in memory. So they created what they call reservation, and they made a reservation window, which is pretty much just saying, hey, those 8 blocks or whatever, how long you specify through the ioctl command, those blocks are reserved for this specific inode. Nobody else can use them. So at that point, you're going to be able to write your file in full, or at least a big part of it. And whenever you close or you crash, this was 100% in memory, so it will get completely deleted and there's nothing missing. There's no problem there, because if you were writing, everything's in the journal and you don't need a reservation window at that point because you're just completing whatever is inside of the journal. So that's the way that they kind of fixed their pre-allocation problem, which I find really interesting. Now, the last big feature change that we have is online resizing. Now, you need to understand that online resizing was brought about because of the Logical Volume Manager, LVM. Now, LVM, for those who don't know, is a weird way to be able to manage your partition, well, your volumes, which allows you to use multiple drive and extend dynamically while your computer is running your partition under those drives. So you could have 3 drives and have one big partition across those 3 drives, and then add another drive to it and resize on the go your partition. Now that's really great, but we need a file system that is able to fit with that, right? We need a file system that is able to grow with LVM in order to make that work. So for that, they kind of make a little protocol with EXT3 that works in 3 parts. The first part is that they expand the last partial block group. So at the end, if ever you would have just a small block group that was cut off by the end of your drive, they would fill that up. After that, they would add new entries to the group descriptor table to fill up the whole group. That has a limit to it. It's 16 gigs for 4K block size. So if you were hitting that 16 gig limit, normally that would be the end of it. You couldn't grow any further. Now, for those that patched their file system, there was a way to go a little bit further. But for the standard file system, that was the end. That was how much you could grow at maximum 16 gig. But anyway, if you've patched your file system, you would have been able to grow it even further than that and go as far as you want. So they would add a new block to the group descriptor table and then add new groups to that block. So that's pretty much all the features that we're going to talk about today. There is more that we can review real quick. We are going to go into the schematics. We can see that there's been a couple of changes in the super block. We have some new keys. In the super block, the changes are in yellow. We can see that we have now some place to be able to set if the file system is compatible with said feature. We can see there are some journal relating places. And if we go to the inode side of thing, we can see the special inode. Inode 8 is for the journal. So that's actually how they know if there's a journal or not. They're able to look at inode 8. And if there's something, well, they will be able to run through that journal knowing that the file system has crashed. Now, there's also another change that happened towards the directory where to be completely honest with you, it happened on the second version of EXT2, but we didn't really talk about it. Of course, we were covering the first version, but with the second version of EXT2, we now have a file type. And EXT3, of course, has the same file type, which makes things way faster whenever you're trying to search for some file or know whatever you're looking at, because you can now see, is it an unknown file? Is it a standard file? Is it a FIFO? Is it a directory? You can know that information without actually going and checking the inode, which would make an ls command way faster. Now that's pretty much all there is to this video. I hope you enjoyed. If you did, of course, leave a like, leave a comment, subscribe, do all the good things that you do, because I love it. I love your interaction and I want to see more of it. Now I'm going to try to give you the H3 video next week, and I'm going to try to stick to a 1 video a week schedule because I really like posting, but God, do I have things to do in my life. So we're going to try to go for a 1 video a week. I hope you enjoy. Please subscribe again if you like this video, and of course, take care.